When you watch the Winter Olympics, you see speed, power, precision. But behind every gold medal performance, there's something invisible controlling it all. Math. From the split-second timing of bobsled runs to the exact launch angle of ski jumpers. The Winter Olympics is basically a giant physics experiment on ice and snow. Today, we're breaking down the math behind 5 incredible sports: bobsledding, curling, luge, ski jumping, and snowboarding. Let's dive in. Bobsledding looks simple. Push hard, jump in, go fast. But the math behind it, it's intense. At the start, teams rely on Newton's second law. Force equals mass times acceleration. The more force the athletes apply during the push, the greater the acceleration of the sled. But here's the twist. Heavier sleds have more momentum. Momentum equals mass times velocity. More mass means more stability at high speeds. But too much mass reduces acceleration. So teams calculate the perfect balance between weight and speed. Then there's the curves. When the sled enters a turn, centripetal force keeps it from flying off the track. Centripetal force equals mass times velocity squared divided by radius. Notice velocity is squared. That means if speed doubles, the force increases 4 times. One tiny steering mistake, the math punishes you instantly. Curling is often called chess on ice, but it's really geometry in motion. The goal? Control trajectory and friction. When a stone slides, friction slows it down. But sweeping changes everything. Sweeping reduces friction by slightly melting the ice surface, which changes how far the stone travels. Then there's the curl. As the stone rotates, it follows a curved path due to asymmetrical friction. Players must predict angle of release, rotation speed, ice temperature, and distance to target. They're solving real-time physics equations in their heads. Elite curlers aren't just athletes, they're human calculators. Luge athletes race feet first down an icy track at speeds over 140 kilometers per hour. At that speed, air resistance becomes a major factor. Drag force follows this equation. Drag equals 1 to 2 times air density times velocity squared times drag coefficient times area. Again, velocity is squared, so even a tiny increase in speed dramatically increases air resistance. That's why athletes lie completely flat. Reducing surface area by just a few centimeters can shave hundredths of a second off a run. And in luge, hundredths of a second decide medals. Ski jumping is pure projectile motion. The jumper leaves the ramp at a precise angle and velocity. The flight path follows a parabola. The key variables: launch angle, initial velocity, gravity, and wind resistance. Without air resistance, the optimal launch angle would be 45 degrees. But in reality, ski jumpers launch closer to 35 degrees. Why? Because aerodynamic lift changes everything. By forming a V-shape with their skis, athletes create lift, similar to airplane wings. So the math becomes a balance of gravity pulling down lift, pushing up, and drag slowing forward motion. It's not just a jump, it's an engineered flight. Ever wonder how snowboarders land 1080s and 14T40s? It's all about angular momentum. Angular momentum equals moment of inertia times angular velocity. Once in the air, angular momentum is conserved. That means if the rider pulls their arms in, they spin faster. If they extend outward, they slow down. Exactly like a figure skater spinning. Judges also evaluate amplitude, which depends on vertical velocity at takeoff. The higher the takeoff speed, the more time in the air. More air, time equals more rotations. But more rotations equals harder landing physics, because gravity is still waiting. The Winter Olympics isn't just strength and courage. It's acceleration curves, it's friction coefficients, it's parabolic motion, it's aerodynamic optimization, it's math, moving at 140 kilometers per hour. So the next time you watch an Olympic event, remember, behind every medal is a perfectly calculated equation. If you love seeing how math powers the real world, subscribe for more videos breaking down the hidden equations behind everyday life. Because math isn't just numbers, it's the reason champions win.